Hi students, this is Mr. Boyd. In this lesson, we're going to learn how to write an algebraic proof. But before we can do that, we've got to understand what the properties are for equality in order to justify our proof. So let's go ahead and get started. This is section 2, topic 2 of the Algebra Nation workbook. So our essential question for the day is, how do you solve an equation? And we will likely be tackling this essential question for a couple of days. Okay? So first thing we want to do is identify what properties are being used in this table. And then from that, we can come up with our properties. So the way we do this is first of all, we want to analyze what was being done or what is being done to both sides of this equation to solve it. Well, when I look at this first example, I notice that here they're adding 7 to both sides. So that would tell me that we're using the addition property of equality because I added to both sides to solve the equation. In the next example over to the right, I can see that we subtracted 4.8 from both sides. Therefore, this problem is using the subtraction property of equality. Okay, let's move on to example number 3. Well, I see in example number 3 we've got subtraction, and in example number 4 we have addition. So that tells me that this is the subtraction property of equality, abbreviated SPOE, and the one on the right is the addition property of equality, abbreviated APOE. Make sure you know what those abbreviations stand for, though. All right, moving on to our next example, I see that they divided by 5 on both sides to solve this equation. Therefore, this would be the division property of equality. Otherwise abbreviated DPO. And then if I move on to the next example, I can see that they multiplied both sides. So that would be our multiplication property of equality. And these properties are what allows us to do the things that we do. Because we know that if we add the same thing to both sides, we end up with the same answer on both sides. So multiplication property of equality is abbreviated MPO. All right, the next one we see here is what did we do to go from this step to that step? And this should be a familiar property to you because this one is the distributive property. We've been using that throughout several lessons. Now, when I analyze this next one, I notice that this 3x moved over here and the 10 moved to the right. Like they traded spaces. Okay? That's what we call the commutative property because they moved. This happens to be the commutative property of addition because you're adding the terms together. And the advantage of that property is that you can move things together that are alike. For instance, here we have our two like terms side by side, so it makes more sense to add those things together. Okay? So the addition property of equality basically says if A equals B, then if I add some number, we'll call that number C, to both sides, we get the same answer. For instance, 3 is equal to 2 plus 1. Well, if I add 3 to the left side and I add 3 to the right side, I still end up with 6 on both sides. Just proving the use of the property. So for subtraction, says if A equals B, then if I subtract some number C, I end up with the same result on both sides. Multiplication follows the same logic. If I have A equals B and I multiply by some number on one side or on both sides, I end up with the same result. And division is likewise A divided by C would be equal to B divided by C. Distributive property we've already done several times. Let's write it out again. AB plus AC, or A times B minus C would be AB minus AC. Again, we're just multiplying each term by that term in front. Commutative property says if I have A plus B, then I can change the order of that addition problem, or if it's a multiplication problem, I can change the order of the multiplication problem. There is no such thing as a commutative property of division or subtraction, because if you change the order of a division or subtraction problem, the answer is not the same. All right, moving on to algebraic proofs. So the first line of every proof, whether it's algebraic or geometric, has the given statement on it. So you write the equation that you were given. In this case, it's x divided by 2 plus 13 equals 45. We're asked to prove that x equals 64 using our properties. The reason that I give for writing that down is that that's what was given to me. Okay? So step 2, what I need to do to solve this is I need to subtract 13 from both sides. That gives me x divided by 2 equals 32. Well, what property did I use to get to line 2? I used the subtraction property of equality because I subtracted 13 from both sides. Next, how do I go to the next line? What do I do to isolate x further? Well, in this case, I'm going to need to multiply both sides by 2 because in the original problem I was dividing by 2, and you use inverse operations to solve equations. 2 divided by 2 is 1, which leaves me with x, and 2 times 32 is 64. What property did I use? I used the multiplication property of equality. And there I have now proven that x equals 64. All right? I'm going to skip that next your turn. You're welcome to do that and check the notes later. I'm going to go ahead and jump to this next worked example, and as always, on the first line, I'm going to put my given statement. So 4 times x plus 2 equals 32, and that's my given. That's what I was given it right here in this problem. I'm asked to prove that x equals 6. Step 2, I would have 4x plus 8 equals 32. What property did I use to go from step 1 to step 2? Well, I used the distributive property. Okay, moving right along, I see that I need to subtract 8 from both sides to solve this equation. So on line 3, I would have 4x equals 24. What property did I use? I used the subtraction property of equality. Okay, what do I need to go to line 4 so that it says x equals 6? Well, it looks like to me I need to divide by 4 to get that x all by itself. The inverse of multiplication is division. What property did I use to get there? Well, there I used the division property of equality. Okay, so I hope you guys found this helpful. If you did, click subscribe and you'll have access to all of my videos when they come out. Thanks, guys. Have a good day.